My computer.
Can you guys see our
Oh
screen?
boy. Yes, we do. Isaac and Dan.
Okay. So my name is Isaac Choi,
My name is Daniel Huang.
and we're seniors at Glenelg High School that make up the Cosmic Dust Collection Team.
Our
Okay.
problem is to develop a solution that will collect and contain cosmic dust from the exterior of the ISS in a non-contaminated way. Finding pristine cosmic dust on the exterior of the ISS, finding pristine cosmic dust on Earth is generally impossible because all cosmic dust that is on Earth has been contaminated by the Earth's atmosphere in some way. Researching pristine cosmic dust is crucial for researchers and scientists because we can find more about the origins of the universe and discover potential life forms outside of Earth. This is why there's such an emphasis on the fact that dust cannot be contaminated so that the information won't be mistaken for things on Earth already. Furthermore, a previous mission done by NASA in 2006, they were able to collect a sample of pristine cosmic dust, and researchers were able to find the presence of glycine, which is an amino acid used by living organisms. We conducted a survey to see how beneficial researching cosmic dust truly is. And in our results, we can see that there's a lot of research benefit for researching cosmic dust because a lot of people found it significant to find new life forms outside of Earth, which is which stresses the importance for us that when we collect the cosmic dust, there shouldn't be any contamination, or else it would be no different from collecting cosmic dust on Earth.
So to know a bit more about cosmic dust, we have to take a look at the background. Cosmic dust comes from like debris off of comets, asteroids, or meteorites. And as Daniel mentioned earlier, this can explain more about our universe because of these extraterrestrial life forms that can be found within these particles. These particles tend to be very fine and have a huge rate of porosity. And in comparison to household dust, we see that cosmic dust is around zero point 0.1 micrometers, while household dust ranges from 16.1 micrometers to 14.9 micrometers. So, to help tie into how we're going to collect cosmic dust, we looked at a couple of products on Earth that collect similar substances. The problem with most of these devices were that they used vacuums or filters. Vacuums aren't a viable option on the exterior of the ISS because there is a lack of air that can be used to create this vacuum. Our other option of using a filter is also not a viable way to collect dust as well, because how do we get the cosmic dust to circulate through the filter system if the cosmic dust is on the surface of the ISS?
Here are some of the past solutions people have done to either collect cosmic dust or regular dust in a contaminated or non-contaminated way. We noticed that the aerogel solutions were the best solutions in the past because they are able to entrap cosmic dust particles in a non-contaminated way while not damaging them at all. However, after consulting with Dr. Horiani, who is a PhD professor in physics at the University of Colorado, we determined that aerogel solutions are not viable for our application because the cosmic dust that we are trying to collect is stationary, and aerogel is only good at entrapping high velocity particles.
So to look a bit more in depth of these prior solution methods, we have to look at silicone oil and silica aerogel. What both of these products have in common is that they both capture these micro-sized particles and it captures them intact. There's no damage left to these particles, but residue can be left onto them, but there are removal methods.
When considering our solution, here are the main criteria and constraints we have to consider. Firstly, our solution must be able to collect and contain cosmic dust in a non-contaminated way, where the tool is able to collect the dust and the dust is able to be transported back to Earth for research. Furthermore, the tool must prevent contamination and accommodate the physical needs of astronauts as they have thick space gloves and are limited in mobility with their spacesuit. Whatever material we use must withstand extreme space temperatures as low as negative 250 degrees Fahrenheit and up to 250 degrees Fahrenheit. The maximum height of our tool must not exceed 1 feet. Here, given our specifications, we ranked them and we created 15 different designs. And after consideration of all the specifications, we chose to stick with the paint roller concept with a detachable head with no residue tape or another adhesive that does not contaminate.
Here's another slide of other designs that we considered, but we still decided to go with our roller design. So looking further into the roller design, we had to look at how viable this option was. We thought that this design is fairly realistic, as there are products that are similar that are used on Earth. For example, a paint roller. A couple of changes that we would need to make is that our handle would need to be ergonomic and easy to use for these astronauts with these big bulky space gloves. We would also need to find a reliable adhesive that would be able to visibly show this dust. Because this dust is so fine, there are potential issues of seeing this cosmic dust on the roller.
When considering our roller solution, here are some of the parameters that we need to consider. Firstly, our main consumers are astronauts and researchers. And again, as Isaac said, the tool must be easy to use, including an ergonomic handle. The roller should be a bright color, but not produce a glare or red, because red signifies emergencies on the ISS, and glares are a safety hazard. However, a bright color is useful because it contrasts with the color of cosmic dust. And since cosmic dust particles are already so fine, it helps astronauts visibly see the dust. Furthermore, whatever container we use must be able to fully entrap it away from any outer environments, as that can cause contamination, and it's also a respiratory health risk for astronauts to inhale when they're inside the ISS.
So looking at our project proposal, we decided to come up with a sketch of what we have in mind. We decided to definitely stick with the detachable roller head with a non-residual adhesive. What this would mean is that this head would be rolled over these patches of cosmic dust, and then we would use a slider design on the back cover portion of the roller to slide off this detachable head into a container. So here's a bit of our mock-up of this happening, where we have the slider going, and as you can see, we slide the detachable head into a canister, which can then be stored. We have to make a couple of changes to make it easier for astronauts to use, as there's a couple more fun work, but this is mostly just to get the design into action, just to get something going here.
Here is our CAD of considering our mock-up design. We decided to try out another concept, a slider concept, where this time we have a pin and there's indentations on the roller. However, after 3D printing the design, we realized that we like the other slider concept better. And if we can just show our camera here. Can you see us, Dr. Gold?
Yes.
Yes.
Okay, so here is
Hold it up.
our prototype.
There you go.
And the roller would be here, and then the slider would go through here. However, we realized that we like the other concept.
Where on this concept, we have a nice big knob here that can easily be slid across to slide the roller off into our container.
Mm-hmm.
So we'll get back to our presentation real quick. Go right back there. Okay. So after analyzing, sorry about that. After analyzing our 3D print a bit more, as Daniel mentioned earlier, we do like this slider design, but we thought to go with a big knob on an attached slider rather than a pin method, as our slider needs to be ergonomic. But regardless of which slider design we have to go with, we have to incorporate this removable head.
Thank you guys for your time. Do you guys have any questions?
Oh, wow. I have a comment. I always learn something when you present. So your research that you do on these projects and your surveys are really cool. So I appreciate that very much. And your PowerPoint was professionally done. So that is really cool. So were you thinking of using the no residue tape?
We were, however, when we were consulting with the PhD professor from the University of Colorado,
Yeah.
he said that there are temperature concerns with the tape where we don't know how well the tape would fare in those situations. And also, since the cosmic dust particles are so fine, we don't even know right now if astronauts can even like visibly see themselves collecting the dust.
So what were you thinking of using for your tape to collect it?
Currently, we don't have a specific lead right now. We're looking through a couple of options, but we definitely want to go along the lines of non-residual and temperature resistant.
Right now, our first line of approach is to get so the professor recommended us to buy this fine grade of dust, which is very similar to the size of actual cosmic dust particles. And he wanted us to see if we can try our roller design and just see if we can actually see ourselves collecting the dust, first of all. And then after, we would look into adhesive solutions.
Okay, so I'm always worried about safety first, right? So
Right.
Yes.
now when you're talking about a fine grain thing that's like cosmic dust, I want you to wear gloves and mask if you're
Yep.
going to use that. All right. So as I want you guys to be able to be our future engineers figuring out all these problems. So make sure you take care really well. Was it expensive dust or what was the
Um, Price won't really be a concern as he offered to send us a sample, or we could reach out to the University of San Diego and they would send us a sample as well.
oh my goodness. So where how'd you get in contact with this with the professor at Colorado, University of Colorado?
So we were actually like just researching, or one of our research phases, we were just looking at a bunch of articles and sources, and
Mm-hmm.
I was actually interested by one of the articles I read on a project the University of Colorado were doing to collect cosmic dust and another application, which was the aerogel solutions. And
So
I was
you
intrigued by
contacted
that.
them.
Yeah,
That is so cool. And they're so willing to help you,
Definitely, yeah.
which is really cool too. Is that in is that in Boulder, Colorado? Is
yeah, Boulder, correct.
okay. Because they do a lot. Bioservice there. They do a lot of space research.
Yeah.
Um,
So he was really enthusiastic to help us out and stay in contact with us. So
yeah. Do you want to go to the University of Colorado? Uh,
maybe. We're
maybe.
not sure yet. Yeah.
It's pretty cool. You should visit. It's really cool up there in Boulder. It's really nice.
Yeah.
Um,
So try to
go ahead,
find out
Stacy.
also try to find out also what kind of uh, safety methods they use when they work with this dust,
hmm
uh, and you need to try to incorporate the same type of things, right? Because you definitely don't want to inhale it. You don't want it to get in your eyes
Correct.
and and things like that. But I'm sure if you would find out what kind of you know personal safety equipment they use when they handle it, that would probably be acceptable as well. Um, but so the things that you have to be thinking about here is how how do you protect from when they're out, right? So so you've got to collect this and put it in its bag when you're outside the station, based on
Yes.
what you told me, right?
Some sort of container method. Yeah.
Yeah.
Right. So number one, this thing cannot eject from the roller before you want it to eject from the roller.
Yeah.
Right.
So what safety are you going to put in place? Which means there has to be at least a two-step method before the thing would be loose enough to come off the roller. Okay, and then and right, you've already talked about doing it with the gloves, and you've got to keep in mind that it's these gloves, right? And so you also probably need to think about they only have two hands, so
Yes.
you need to use something that's going to maybe provide them a third way to stabilize something, so that they can use both hands, because you're talking about you're right, trying to release something and hold the container that it's going to go into, and this type of thing. So really think through that, okay?
Okay.
Uh, and yeah, and make sure you're wearing some big gloves when you practice this.
Definitely. Yeah.
Yeah.
That's like one of our main concerns about our devices, making sure that we can use these big bulky gloves with this device.
hmm
Absolutely.
Bless
Very
you.
good.
Thank you. Appreciate that. And then, do you have any other questions or comments about this, or something that just really stood out to you?
Well, I like the fact that you realize that this is all being done outside
Hmm.
the space station, right?
Yeah.
That you're not going to take it in and expose it to the environment inside, and that you're preparing a process for making this happen. And so, I mean, it could connect to their leg where they stick this in and then release it, uh, or something along that lines. But that's I'm interested in seeing what else you come up with how to capture this and enclose it outside.
Mhm.
Okay.
Mhm. And so take videos. We need to for your testing. And if the cosmic dust is a white powder, I don't know what color it's going to be, but take videos and make it contrast with the background so we can really see in the video what is happening.
Okay.
Mhm.
Sounds good to us.
Yeah. No, you're doing a wonderful job, and I sure appreciate all the work and research and time that it just went into your PowerPoint just now. It was
Thank you
awesome.
so much.
Absolutely, great job.
Thank you so much for your time. Sorry
Okay.
about the short notice, but
And
we
you
really
can
appreciate it.
always ask us questions. Just copy your teacher.
Okay.
Okay.
Okay. All
Sounds
right. Well, you have a wonderful afternoon now. You don't have to worry about it, and you have a good lunch.
yeah. Thank you so much for your time.
Thank you for all your
Very
work.
good.
Okay. Thank you. Stacy, thank you for coming back. And
Oh,
then
you're
we just
welcome.
we just have Olympia at
Okay.
11 your time. I really appreciate Stacy. Your
Okay. Oh, no problem.
suggestions are wonderful.
My pleasure, Flo. We'll
Yeah.
see you at 11.
Okay, thank you. Yeah.
Okay. Bye bye.
Bye-bye.